welcome back to the fourth lesson in Unit 3. We are going to be solving, again, quadratic equations. However, today we're going to use quadratic formula, okay, to solve quadratic equations. Before we do that, I would like you to review on solving equations by completing the square. So go ahead, give it a try, and I'll show you the answer in a bit. Alright, so here are the solutions for these two or more questions. The first one is a standard one, so you just follow procedures that from what we learned last class. That's what you get. Part B, again, we just need to follow the procedures, and then you should get all the way till here. Okay, now from here, I do notice that I have x minus 1 squared, and that is equal to negative 5 over 2. Actually, from here and on, I don't need to solve this equation anymore. I can say that the answer is no solution. And how do I know? Well, because it's something squared and equals to a negative number. And I know that is impossible, right? It's not possible to have something squared and, it becomes a negative number. That's just not possible. So we know right away that there's no solution. Okay, so that's no solution. All right, so that's what we did last time. And I have a challenge for you. So this is a regular quadratic equation. However, in the previous two questions, there were numbers, right? But this time we have just variables a x squared plus bx plus c, so abc, for this quadratic equation. Try to solve this equation with completing the square. Okay, so your answer will not be a number; you'll be an expression. Okay, give it a try. Okay, see how you do it. Okay, if you get it, great. If you don't, I'm not too worried about it, but I would like you to try it, okay? I will show you the answer in a bit. Okay, so as you can see, my first step was factoring out a. So then, that's the leading coefficient. So I get a times x squared plus b over x. And then there's the second step. I took the coefficient in front of x, b over a, divide that by 2, you get b over 2a. And then I'm going to add b over 2a squared, which I get b squared over 4a squared, and then minus b squared over 4a squared. Okay, and now the next step is I took out this negative b squared over 4a squared outside of the bracket by multiplying by the leading coefficient of a. So I end up with negative b squared over 4a over here. Now, because I'm adding fractions, so I'm changing c to 4ac over 4a. Okay, so then after that, this was a perfect square, so I factor that, and that was x plus b over 2a. Remember, this is always half of the middle term right there. And I combine these two fractions together, I get minus b squared minus 4ac over 4a. This was a minus sign because really what we did was we combined these two together, but that was a minus sign here. So you see minus negative 4ac, it really is a plus 4ac here. And then I'm trying to isolate for the squared term. So I move b squared over minus, so I move this term to the right. So I get that. Divide both sides by a, you get 4a squared over here. And now you take the square root of both sides, so you get x plus b over 2a is equal to plus minus square root of that. Finally, to solve for x, we move b over 2a to the right. That becomes negative b over 2a. Now this side, for this radical sign, you can see it's square root of 4a squared in the denominator. So when you square root that, you actually get 2a here. And now because they are the same denominator, so really we can rewrite this as one single fraction. So that's negative b plus minus square root of b squared. Oh, wait a minute. Just realized I made a mistake here. This says b squared minus 4ac. I don't know why when I move it over, I turn that into a plus 4ac. Okay, that's better. B squared minus 4ac. B squared minus 4ac. B squared minus 4ac. And that should be b squared minus 4ac. There you go. This is your quadratic formula. Okay, so you can actually solve any. So, the good thing about having this expression is that this can solve any quadratic equation. Okay, any. It does not matter if it's factorable. It doesn't matter if there's decimals involved, fractions involved, you know, sometimes it's not easy to complete a square, right? Because you end up with fractions. But this will solve any quadratic equation. So here are 3 examples I'm going to show you, okay? So what you need to do, okay, is here is a quadratic equation, right? Always make it equal to 0 first, okay? So which this is already equal to 0. You need to identify the values of a, b, and c, okay? So you can see here, this is 1x squared, so a is equal to 1, b is equal to 2, and c is equal to -7, okay? So again, a, b, c. Okay, and now once you have your ABCs, your values, then you can apply this to quadratic formula. Again, the formula is -b plus minus the square root of b squared minus 4ac divided by 2a. Okay, so now what we need to do is just plug in the values. Okay, -b, so -2, plus minus the square root of b squared, so 2 squared, minus 4 times a times c divided by 2 times a. Okay, so now we just need to, well, I just realized I write way too big. Okay, it's taking all the space over here. Let me draw the line over here so I don't overtake the space there. So -2 plus minus 2 squared minus 4 times a times c divided by 2 times 1. So this is -2 plus minus 2 squared is 4. 4 times 1 times -7 is actually positive 28 divided by 2. You can simplify this a little bit. That's -2 plus minus root 32 over 2. Now root 32 can be simplified. Remember, this is 16 times 2, so that really is 4 root 2 over 2. Okay, and now we can divide everything by 2, so then you should get -1 plus minus 2 root 2, and that is the answer. So x equals to either -1 plus 2 root 2 or -1 minus 2 root 2. Okay, you can do the same thing with part 2, so I'll let you try it. Again, first step is to identify the a value, b value, and c value. So go ahead, give it a try, and I'll show the answer in a bit. Okay, so for the second example, again, you just plug in these 3 values. Hopefully that's what you got for a, b, and c. A is 1/2, b is -5, c is 10. Once you have identified the values, you plug into the quadratic formula, and then just do what it says, right? Negative of -5 is positive 5, plus minus the square root of b squared, -5 squared is positive 25, times minus 4ac, so 4 is 4, a is 1/2, and c is 10. Multiply them together, you get 20. Divided by 2a, so 2 times 1/2 is 1. So then you just, again, simplify this. 5 is 5 plus minus square root of 25 minus 20 is 5, root 5. And that's it. Divided by 1, you don't need to do that anymore, right? So that's the answer. Okay, last example, part C, or the third one here. So this one is not equal to 0. So what you need to do first is to make it equal to 0. Okay, so what you need to do is to expand and move everything to one side. Okay, so we need to FOIL this. So this is going to be 2x squared minus 2x plus x minus 1. I'm going to move the 5x to the left by subtracting 5x. And now you can combine like terms. You get 2x squared minus 6x minus 1 equal to 0. So then you can see a is equal to 2, b is equal to -6, and c is -1. Okay, so then again, you can plug this into your quadratic formula. I have a little bit more room here, so I'm going to write down the formula again, just in case you don't remember what it is. So -b plus minus square root of b squared minus 4ac divided by 2a. And now we can just plug in the numbers. -b, so negative of -6, plus minus square root of b squared minus 4. So -6 squared minus 4 times a, which is 2, times c, which is -1, divided by 2a, so 2 times 2. So this is going to be 6 plus minus Negative 6 squared is 36. Minus 4 times 2 times negative 1 is plus 8 divided by 4. And then we can add them together. That's a 44. And now again, 44 can be reduced, or root 41 can be simplified. That's 4 times 11. So it's going to be 2 root 11 divided by 4. Finally, divide everything by 2. So you can reduce this radical. You get 3 plus minus root 11 over 4 as your solution. Okay, so that's how you do, or how you solve these quadratic equations that are not factorable. And you don't need to complete a square as well. Completing a square, it's not always the easiest. Having said that, though, you could also easily make mistakes using quadratic formula. So, regardless, you just have to be really, really careful. Okay, hopefully that was clear for you. Okay, we are going to move on to solving some word problems. Okay, so here it says Josie's rectangular garden measures 9 meters by 13 meters. So we have a rectangular garden, 13 meters by 9 meters. She wants to double the area of her garden by adding equal lengths to both dimensions. We're looking for this length to the nearest centimeter. Okay. Okay, well, we actually do know what the area is right now, right? 13 times 9 is 117. So the area right now is 117 square meters. Now, she would like to double the area. Okay, so again, recall area is equal to length times width. Okay, now she would like to double the area. So the new area is 117 times 2, which is 234. Okay, so the new area is 234. Now, obviously, if there's if the area is doubled, then that means the length and the width would have to change. And the question says she would like to double the area by adding equal length to both dimensions. So we're adding equal length. So we're adding, let's say, x, right? We're adding x to each side. So now you can see a little bit bigger now, right? Something like this. It's going to be a little bit bigger now. So the equation that we're going to end up with is going to be 234 is equal to length, which is 13 plus x. You know what? I'm going to write x plus 13. I just like to write variable first. Times x plus 9. Okay, so there is our quadratic equation. Now again, once we have the quadratic equation, we can solve this by first expand and make it equal to 0. So I'm going to move 234 to the right by subtracting 234 at the end. Okay, so if I expand this, I get x squared plus 9x plus 13x. You should get plus 22x plus 13 plus times 9. We just multiply that. We get 117. And again, we need to move the 234 to the right. So by subtracting 234, so your quadratic equation becomes x squared plus 22x minus 117. Okay. And so now what you need to do again is then use the quadratic formula to solve this, because I do not think this is factorable. Okay, so we need to use quadratic formula. So then again, identify your values of a, b, and c. So a is 1, b is 22, c is negative 117. So now I can plug this into the formula. X would equal to negative 22 plus minus b squared minus 4 times a times c divided by 2a. Okay, now you need to put this into calculator. Okay, 22 squared. Okay, I don't know what that is. Let me put that into calculator here. Okay, so 22 squared is 484, and then minus. We have a negative sign there, so it's going to be a plus. So we're going to have 117 times 4, which is going to be 468 divided by 2, 484. Okay, so then we have negative 22 plus minus 482 plus 468, 484 plus 468 is 952 divided by 2. Now in the question, it does ask us to round to the nearest centimeter, so we could just plug this into calculator and see what we get. Okay, so we are gonna go -22 plus square root of 952 and then divided by 2. This is, so one answer is 4.43 meters. Okay, if we do it by subtraction, that's our x2, so second answer. So that would be -22 minus square root of 952 divided by 2. You would get -26.43. Now clearly we need to reject this answer because x is the length that we add to the shape, to this area, to this garden, and we cannot add negative length to it, right? So we know we need to add 4.43 meters. Now it's as though we are determining this length to the nearest centimeter. This is meters. So recall, to round, what you need to do is you need to multiply from meters to centimeter. What you need to do is you go 4.43 times 100. This is 443. Oh, sorry, not meters, centimeter. Okay, that's how you convert meters to centimeter times by 100. Okay, so that's the first example. Now we're going to move on to the next example. Here it says a person is standing on a bridge over a river. She throws a pebble upwards. The height of the pebble above river h meters is given by the formula right here. H is equal to 26 plus 9t minus 4.9t squared, where t is the time in seconds after the pebble is thrown. Okay, part A, it says, when will the pebble be 20 meters above river? Okay, so to solve this question, what we need to do is, well, I guess we need to first understand h, again, is the height. Okay, height of the pebble above water, above the river. T is the time. Here it tells us when is it going to be 20 meters above the river. So what we need to do is we plug in 20 into h and we solve for t. Okay, so that's a quadratic equation. So to solve for t, we need to, again, make it equal to 0 first by subtracting 20. So we get, again, I'm going to rearrange this. So then we have t squared goes first, plus 9t minus 20, so you get plus 6. Okay, and now once we have the equation set up here, we then can use the quadratic formula. Again, this is not factorable, so then you just need to plug it in. So t would equal to -b plus minus b squared minus 4 times a, which is -4.9, times c, divided by 2a, so 2 times -4.9. Okay, so I'm going to ask you to put this into calculator. Well, actually, you know what? Let's simplify this a little bit first. This is going to be 81 plus, that's going to be 24 plus 24 times 4.9 times 6 is 117.6 divided by -9.8. Okay, so this is going to be -9 plus minus, so 117.6 and then plus 81, that's 198.6 divided by -9.8. So then we just need to put this into calculator, okay, and see what we get. So again, you have two options. You could do the plus sign or the negative sign. Okay, so we'll do both. See what happens. -9 plus the square root of 198.6. Okay, I end up with a positive value. Okay, divided by -9.8. Now, if you divide it by -9.8, I believe you get -0.52. Again, this is not possible because time cannot be negative. So we have to reject that answer, and then we're going to do the second option, which is -9 minus square root of 198.6 and then divided by negative 9.8. We get positive 2. We want to round to the nearest tenth, so 2.4 seconds. Okay, so that will be the answer. So now I'll let you try part B yourself and see how you do. It's the same question, basically, it's just different values. Okay, so give it a try. Okay, so this is what you get. You should get two answers in this case, actually, 0.8 seconds and 1.1 seconds. Again, that's your equation, and then you just basically follow the same procedure. You should get these two answers. Now, here is the interesting part, okay? Part 1 has one answer, or part A has one answer, part B has two answers. Why? How come part A has one answer only, but part B has two answers? So I guess that's the question for part C. How come? Why are there two answers in part B, but only one in part A? You think about it. Okay. I don't know if you thought about it. Whatever, it doesn't matter. Well, hopefully you did. If you didn't, that's okay. I'll tell you why. Okay. So if you look at the equation, okay, I mean, you can think about it why. You can already get the answer from the equation, but let's read the question again. It says a person is standing on a bridge over a river. So one possibility, if you just think about the scenario, it says when will the pebble be 20 meters above the river? Well, it only happened once here because this person was already standing on a bridge, and this bridge is probably taller or higher than 20 meters above river, right? If it's already above, if it's already higher than 20 meters, so when you throw a pebble up, it's not gonna hit 20 meters again, right? It's only gonna go down. It's gonna hit 20 meters mark when it's falling downwards, and that's why there's only one time. Whereas 30 meters, you could hit twice. You could hit 30 meters twice on the way up and on the way down. So what I'm saying is, there are two answers in part B and only one answer in part A because the bridge is taller than 20 meters, but shorter, but not as high as 30 meters. Okay, and that's why, so you can see, so, okay, here we go. My terrible drawing, here we go. So here's the bridge. Is that even a bridge? Oh my god, what is this? Okay, so okay, oh man, okay, you gotta bear with me, okay? This is the bridge, and here's the person, right? Here's the water, I guess. Okay, so this person throws the pebble up and falls in the water like that. Okay, so what I'm saying is 20 meters is probably somewhere here, and 30 meters is probably somewhere here. So if I drew an axis right here like that, 30 meters is probably somewhere here. So you can see when this person throw the pebble up, it actually hit the 30 mark once and hits the 30 mark the second time right there. Whereas 20 meters, it only hits it right here. And that's why you have, so this is 30 meters mark, 30 meters mark, and this is 20 meters mark. That's why you end up with two answers in part B and one answer in part A only. Okay, and again, you can tell actually from the equation. You see, this is 26 right here. That 26 tells me that the height of the bridge is 26 meters. How do I know that? Because when time is 0, this becomes 0, this becomes 0. So the height at time is 0 is 26 meters, and that's where that's where this person is throwing the pebble. Okay. All right, that's it for this lesson. Do some practice questions. Let me know if you need some